Hello, everyone. This video is aimed to introduce you a new component in the EvoMass tool. Is for the generate building layout. So this can help you to use further expand the utility of EvoMass for a small scale urban design project. So um, so I will use this video to briefly introduce how you can operate this component. So when you download the new EvoMass, you can see that the new layout component is on the tab. Is in here. It's not called because this is just the first version. So there should be still some problem or bugs. So this is just a beta version. So you can drop one of them on the canvas, and then to use the layout component, you need to have like a two input. One is the building massing generated by the additive or the subtractive component. So here I will use two generated component to generate two building massing first. So here is one, here's another one. And the other input is the boundary for the building layout arrangement. So here you can create a building, a boundary, let's say the side boundary of the project. And then you need to draw this on Rhino, and then you click the setup, you select the boundary, and then set. And then the next one is you need to connect the component ID to the layout component. So the component ID is the median to communicate between the building massing generated component and the layout component. So let's disable the preview of the two generated component, and now we can see that the building is generated. The two building is already like put into this boundary, and then you can generate some sample design, and you can see that the two building will change their position within this boundary. And then the second thing is about there's some user-defined setting. Let's say for the building spacing, so you can set up like the value, so the algorithm will try to satisfy the space between the two buildings. Let's say let's set 10. And then we can generate another one. Yeah, you can see that this one, the algorithm is trying to satisfy the spacing constraint. But in some cases, the algorithm cannot handle the conflict between the boundary constraint and the space constraint, so that here you can change priority to either to satisfy the side boundary constraint or the building spacing constraint. Let's say for this example, you can see that if I prioritize the building spacing constraint, you can see that the algorithm will make the building exceed the boundary, but will try to satisfy the spacing requirement. So that this is something you can change first. And the other user-defined parameter is the orientation of the building. So that if you enable this tab, you can change the rotation of the building, let's say from -15 to 15 degree. And then you can see that the two buildings will change, have different orientation. And the other thing is you can also, if you don't want the building just face south, you can also have the same value, so that the two buildings will have the same orientation when they generate the layout. And when you use this component, there's like one thing you should be aware of is that you cannot connect too many building massing component into the layout component because each of the behind each generated component, they will cause a number of parameters to generate the building. So let's say you already have like a 2 building massing generated component, it means like at least like a 50 or 60 parameter. So that if you have too many generated component, there will be, let's say, more than hundreds parameter, which will overwhelm the evolutionary algorithm to solve the problem. So that my recommendation is the maximum number of the building massing, input building massing is 4. And also when you have a 4 or 3 building massing, you also need to reduce the, let's say, the mass number or the subtractor number to a lower value so that they will also reduce the number of parameters to generate the building massing. And the other thing you should be aware of, like this is just for testing. If you really start running the optimization, I will recommend you to another way to connect the building massing to the layout component, so that which you can use the panel, and then you can right-click the 2 building massing generated algorithm component and copy the ID, and then you copy the another one. You need to have a return. And then you need to also to enable the multi-line data so that they will become a list. So with this list, you can directly connect it to that. And then you can still generate the building massing. The algorithm can still extract the building massing data from these 2 algorithms, these 2 components, and then to generate the building layout based on the building massing data. So I will show you in example. This is example you can also find in the zip file you download with the EvoMass GHA. And here there's some instruction already. And then you can see that in here, I use the panel to connect the building massing generated component to the layout component. And then when you start the optimization, you need to connect the evolutionary algorithm, the SSIEA component, to all the generated component as well as the layout component, so that the algorithm will change the building massing first, and then also will provide parameter to precision or to locate to define the location of each of the building massing. So that we will run a short optimization to show you the result. And here you can see check the input. The input is actually the number of parameters used in each of the generated component. You can see that the component 0 is one of the building massing generated component. You already have like a 30 parameter, and the other one, the component 1 is the other one, so also have 30 parameter, and the component 2 is the layout component. So here I have like a 6. So that you can see that now they already have like a 66 parameter. So it is already like a quite difficult for evolutionary optimization algorithm to optimize the problem. So that when you use the layout component, do remember to control the number of parameters in the generated components. So after that, we can start the optimization. So here you can see that the 2 buildings can change their position as well as their building massing at the same time. So this will allow you to optimize the building massing and the layout at the same time, and also to have like 2 different dimensions in terms of the impacts on the building performance. And then you can see that the change of the layout can also, you can imagine this can be more useful in the urban design project, so that you can see how this building massing can also not just satisfy the building performance, but also other dimension like open space or circulation thing. So I won't finish this automation, and then you can see that just show you the effects of this new layout components. And then if you are interested, you can try to use that with this example, and then to explore how this can assist you in your design project. So that's all. Thank you.